Hi, for this recording, I'm going to show you how to find the reduction formula of cosine power nx dx when you integrate them. Alright, so what I'm going to do now is I'm going to use integration by part, which says that if you have f of g prime we integrate, this is equal to f times gx minus integrate of f prime times g. So in this case, I must consider cosine power nx as a product of two terms. One of the way to do this is notice that cosine n power nx dx here is equal to cosine power n minus 1 power n minus x times cosine x dx here. So that means that if I do that, then f of x will be cosine n power n minus 1 x and g prime of x will be cosine x here, cosine x will be cosine dx here. So that will help me to set up integration by part. So let me set here. So fx is cosine n minus 1x, g prime of x is cosine x dx. So I can now find f prime by differentiating. So bring down the power n minus 1 cosine power n minus 2x, and then differentiate cosine x to get minus sine x. And g prime is cosine x, so g is equal to integration of cosine x, you get sine x. So apply the formula again. This one, maybe I simplify first. F g prime is equal to fg minus integration of f prime g. So put this inside. So f times g is cosine power n minus 1x times sine x. And then f prime minus become plus already. Integration of n minus 1 cosine n minus 2x power n minus 2x sine x dx, which I can take out n minus 1 okay, I forgot that I have this one should be there's a minus sine x here, right? There's a sine x here, and f prime g. So f prime g, so sine x to the square. Yeah, this square here. So n minus 1 cosine power n minus 2x sine square x dx. Now I want to use a bit of trigo now, because this is where you start with. I start with integration of cosine power n x dx integrate. So I use the fact that sine square x is equal to 1 minus cosine square x, and substitute. Okay, substitute into my second integral. So this will give me, okay, this part here. I'm going to help over here. So this will help me. In this case, cosine integration of cosine power nx dx is equal to cosine power n minus 1x sine x plus n minus 1 cosine power n minus 2x times 1 minus cosine square x dx here. Now when I multiply them inside, so cosine power n minus 1x sine x plus n minus 1 is multiply, I get cosine power n minus 2x minus n minus 1 integrate cosine power n minus 2 plus 2 get n power n now. So we start with integration of cosine x with power n, and then end up like this. Now you notice that if I look at that similarity, this term and the last term are actually identical, so you can combine them together. So combine, okay, combine cosine x raised to the power n dx integral of this. So I'll get, in this case, this is equal to cosine x raised to the power n integral plus n minus 1 times integral of cosine x raised to the power n equal to, right hand side is cosine power n minus 1x sin x plus n minus 1 cosine power n minus 2x dx. Now, in this case, I'm going to use a label, but let's add up the left hand side. So the left hand side can be combined together. It's actually one copy of raised to the power cosine x raised to the power n dx integral plus n minus 1 copy of integral of cosine x raised to the power n dx. Add together is n copy of integral cosine power n dx integral is cosine power n minus 1x sin x plus n minus 1 cosine n minus 2x dx here. Now if I use a short form, let's call this thing in. So if I call that this is called in, then obviously this is called in minus 2 because the power is n minus 2 now. So I have the integral reduction formula n in is equal to cosine power n minus 1x sin x plus n minus 1 in minus 2. So divide both sides by n. So in will be 1 over n cosine power n minus 1x sin x plus n minus 1 over n minus 2. And this is the reduction formula for integration of cosine x raised to the power n. This is the end of the recording.